This is 1.2, number 31, and this comes at us as a chemical reaction that we need to balance. Well, odd sort of tidbit about myself, my grandfather was a PhD chemist, John Dean, at the University of Tennessee in Knoxville for many years before he passed away. So every time I see chemistry, I always think of him. Okay. Now, we are given this first line, and if you look at what we're given, which is the equation corresponding to oxygen, it can help us figure out what we need to do with the rest. Maybe I'll get my pointer. Here we see 2 oxygen, and here's the A. We see 1 oxygen with the B, and then on the other side of the equation, we see 2 oxygen with a C, 3 oxygen with a D. And if you look at this equation that they gave us in the problem, you see the 2A plus B equals 2C plus 3D. And we're trying to find the smallest ABCD that will balance the equation. Namely, we're going to have a similar equation for N, a similar equation for H, nitrogen and hydrogen. Okay, so here we go. First, let's write these two. What would we have for N? For N, we would have A plus, oh, well, we don't even have a B, right? There's no nitrogen there. A will equal C plus D, okay? And then the last one comes from the hydrogen. You notice on the left-hand side, there's none in the A, but we do have 2B equals, and then we are going to have C plus D. Okay, it looks good to me. Okay. Well, let's just rewrite this so that we have a linear system. In fact, we're almost there. I want to rewrite this, so maybe I will rewrite it this way. 2A plus B minus 2C minus 3D is 0. This is the first equation. Then I have A minus C minus D is 0. Second equation. And the third equation says 2B minus C minus D is 0. This is now translated, and this is not the first question I had this semester on one that was sort of a word problem that we had to translate. Once we wrote down, I should say, the linear system, is not too bad, right? Now we have, well, we have 3 equations, we have 4 unknowns, and it even mentions in the problem that, let's see, while there are many possible values for A, B, C, D that balance, it's customary to use the smallest, right? And we should expect, because look, the biggest, let's write the corresponding augmented matrix, but what we have talked about since, the biggest, if you look at only the coefficients and that matrix, it would be 3 rows, 4 columns. The biggest rank it can be is 3, so you know that you will have a free variable, and you know, for example, that you will have infinitely many solutions here. Okay, well, let's write this. I'm going to write the augmented matrix. We have 2, 1, 0. We have 1, 0, 2. Minus 2, minus 1, minus 1, and minus 3, minus 1, minus 1. And then I will augment it with zeros like this. Okay, so now maybe I'll move it. Maybe I'll leave it. It's fine. I was going to move it over to give myself more space. Let's get a red. Okay, and now we perform elementary row operations in order to solve this linear system. And I will copy and paste. The first thing that I need to do, oh, well, I tend to like to avoid fractions as long as I can, so I am going to interchange row 1 and row 2, just so that I have a 1 rather than having to divide by 2 and immediately introducing fractions into this, because the moment I start introducing fractions is usually, well, 2 moments later maybe is when I start making mistakes. And then I have to re-record. This is the way things go. Okay, so I have 1, 0, minus 1, minus 1, and then I have 2, 1, minus 2, minus 3. I have interchanged those 2 rows. Very nice. What will happen next? Well, now, you see, I already have my first leading 1. So I'm going to take minus 2, row 1, add it to row 2, copy, paste. And what do we have? Minus 2, row 1. Well, this is now 0. This is now still 1. Minus 2, that would be a positive 2. We're going to have a 0. Minus 2 here, that's going to be a positive 2. We'll have minus 1. Okay, looks good to me. And now we keep going, right? In fact, we have our first 2 leading 1s. Leading 1, leading 1. The next thing to do is to turn this into a 0. So I'm going to take minus row 2, add it to row 3. And then again, let me see if I can copy. Paste. Row 1 and row 2, I have not changed. And row 3, this is now 0. This is still minus 1, and now I got to move this to look. That's going to be a positive 2, and then I have a 1. And then there's, let's see, what can I do? I can multiply through by minus 1 here. I'm really almost done with my elementary row operations. You can already see before I even finish that my free variable is going to be x4, because the moment that I take my next step, which is minus 1 times row 3, now I will see my final leading 1, which is in the x3 position. Well, okay, I meant C. We weren't using x1, x2, x3, x4. It was A, B, C, D, but I meant this position. Maybe I don't need to erase. I just multiply through by minus 1. This is a 1. This is a minus 1. And then I have one more step until I'm in. So this is row echelon form, right? I have one more step until I am in reduced row echelon form, which is to add row 3 to row 1. So row 3 plus row 1, and then I will be in reduced row echelon form. And here we go. Add this one, and this one will change. Okay, so this one when I add becomes 0, and this one when I add becomes minus 2. We are in reduced row echelon form. Okay, leading 1, leading 1, leading 1. Look up, look down. In those columns, all you see are zeros. Reduced row echelon form. Oh, it's so nice. And now, I was calling it X4 is our free, and like I said, I forgot these letters we were using, so the D is the free variable column. It's the 4th column. So what is a general solution? Well, if I say D is some T, and then we have that A is to T. We have, maybe I should do it in 2 steps. We have A minus 2D is 0. We have B minus D is 0. And then we have C minus D is 0. Let me make these a little smaller. Uh-oh. I resized only part of that. I think that's okay. Now I'm ready to solve a general solution. If I wanted to write it, would be, for example, this vector. A general solution would be, we have T. Oh, well, we see C is T, B is T, and A is 2T, like this. This would be a general solution if you just add, right, each equation to the other side and substitute T for D. But it asks us for, okay, now we have to read the question. In fact, does it even say here? Okay, good, I kept that part. Look, A, B, C, and D are unknown positive integers. And then it mentions to find the smallest such. So here, if they're all positive integers, the smallest such would be T is 1. It's the smallest positive integer. And so our final answer is here in vector form. It's 2, 1, 1, 1. Or you could give it as A is 2, B is C is D is 1. This would balance this chemical reaction and answers the question. Okay, thank you.